All right? All right, I want you to know it's, what's today's date?
May 7th.
May 7th. And Cinco de May 7th? No. Siete de Mayo. Okay. Oh, Cinco de Mayo passed and gone, huh?
Yeah.
What is Cinco de Mayo?
When Mexico won, like this.
The Pueblos, when they fought the
Yeah, but they lost the war, but they won the battle, right?
Yeah.
Excellent. The Battle of Puebla, right?
Mexican independence.
Battle of Puebla. Okay. I think that's right. Can you look that up? Make sure that we don't put on internationally incorrect information. I think Cinco de Mayo is when the Mexican army beat the French army at the Battle of Puebla, but they lost the war. But they take that as the beginning of their independence from colonial powers, from France. Okay. Now, everybody, everybody. So, Josh, Alan, thank you very much for participating. Excellent. Erica looks very wide awake today. Excellent. Very well rested. Okay, what we're doing, anybody who's following us from another country, I have people following me from Djibouti. This comes from somebody with the name Cody. Sounds like a horse. Okay. Yeah, it's a country. Djibouti's a country in the Horn of Africa. Guys, you know, people can watch this and you're laughing at the name of their country. I think that's, apologize. Excuse me, apologize. They're apologizing. They're apologizing. They're apologizing. Thank you very much. My apologies to everyone overseas. Okay, now. This is a review for tomorrow's test. We're doing Thermodynamics Part 2. This is the third review video. And this particular video is going to cover things like ideal efficiency of an engine. It will cover a very, very brief discussion of the three laws of thermodynamics. Actually, only the first two are mentioned in the book. So we're going to talk about thermodynamics. We're also going to talk about, what else? What else did we talk about? Refrigeration, very briefly, okay? And how the phases, change of phase, can be a cooling process or heating process. And it will be a cooling process or heating process relative to the environment, right? So in other words, you perspire. You perspire. And you form sweat. Okay. Now, is that the cooling process? Sweating? No. It's when the sweat evaporates that you cool. For instance, if you have a very humid day, what do I mean by that? Let me be more specific. And this is our first discussion, called relative humidity. Relative humidity. Relative humidity is the amount of water that can be dissolved in air at a given temperature. Right. Now, when I talked about this with your class and with other classes, what I said was this. I looked at a basic graph, okay, and the graph looked like this. We looked at temperature here, and we looked at, what did we look at? We looked at grams, we looked at mass in grams per 100 milliliters of water, and we looked at two things. We looked at, this is about 30, and this is about 40-ish. So this is 0 degrees, this is 100 degrees. So in other words, this is going to be sodium chloride. In other words, sodium chloride, the warmer the water, the more sodium chloride that you can dissolve in the water. Now, this graph is not exact. Who's there? Okay, this is not exact. It doesn't go necessarily exactly from 30 to 40. The idea is that people think that you can dissolve a lot more sodium chloride in hot water as opposed to cold water, and it's actually very similar. Now, this is what is unique relative to dissolving a salt. Let's talk about a salt called potassium nitrate. Potassium nitrate's like this. The difference between cold water and hot water is remarkable. You can dissolve an enormous amount of potassium nitrate in warm water as opposed to cold water. What does this have to do with relative humidity? Well, it has to do with this. I'm going to erase this. Now, it has to do with this. It has to do with the relationship between solute and solvent. Okay? So potassium nitrate, let me get another marker. These are dying. Potassium nitrate is the solute. And water is the solvent. So, the warmer the solvent, the more solute that you can dissolve in the solvent. Okay? Now, let's look at two others. Let's look at two others. And that is let's look at air. And is air with humidity going to be the solute or the solvent? Air is going to be the solvent. Air is the solvent, and what's the solute? For humidity? Water. Water is the solute. Now, in the same way, the warmer the air, the more water that you can dissolve in the air. Does that make sense to you, Jason? Okay, now, let's think. Think. Summertime, we'll say New Jersey, okay? New Jersey. East Coast, United States, okay? Yes? July 1st. 50% relative humidity. Relative humidity, July 1st. Okay? All right. We'll say January 1st. 50% relative humidity. Okay? Which one has more water in the air? January 1st or July 1st? July 1st. Do you ever do physical activity in the middle of the summer? And you sweat, and you sweat, and you sweat, and you sweat, and you keep sweating. And the hotter you get, the more you sweat. Why is that? Why does that happen? Why does that happen? Well, how do you cool the body? How does the body cool? It evaporates the water that you're sweating, right? Right? Evaporates. So if it's July 1st, would it be unusual to be 95% humidity?
No.
It's always relative humidity. When it says humidity, it's always relative humidity. So it's not unusual to be 95 to 100% relative humidity in the summer. You hear that on the news all the time, right? So what does that mean? What does that mean? Who said that? Max said it means that the air is saturated. Saturated with what?
Water.
Saturated with water. So if it's saturated with water, can you add more water to it? No. And so you are sweating. Can you evaporate? Will that water evaporate off your body? It'll stay right where it is. It has no place to go. So it'll build up. So what's going to happen? Are you going to cool off? No. So what are you going to continue to do? You're going to continue to sweat and sweat and sweat and sweat until what happens? You run out of water. You run out of water. And that's not good. You got to stay hydrated. Okay? So that's when you get overheated. Yes? because you can't evaporate the water from your skin. So you get overheated. The engine, the cooling engine breaks down. The cooling engine breaks down. In other words, I cool my body by sweating. And then the sweat evaporates. The evaporation from my skin will cool my body. If the water doesn't evaporate, what's the body going to continue to do? Produce more water. I run out of water. Bad things happen. The end. Clear? Sounds good? All right?